To start off, let me first welcome you all to the third exciting learning session of Swift Anytime Learning series. And the guest of the session today is none other than Catalin Patrascu. And he is an experienced iOS developer. He has been working in the industry for last 13 years now. And he brings a lot of value to the table today in terms of the topic that we have for the session, which is iOS unit testing. And we will be talking about the fundamentals, why you should care about them, and how you should get started with it. Talking about Swift Anytime, Swift Anytime is a learning platform that helps iOS developers across various experience levels to enhance their skills, expand their knowledge, and prepare for technical interviews. In addition, I would like to mention that Swift Anytime is one of the largest active iOS communities in India, and we are progressing on a path where we would be striving for becoming the most active and largest community in the whole world in iOS. Talking about me, I am the founder and CEO of Swift Anytime. I am having more than 5 years of experience in the industry professionally. And ever since I got started into the industry, I always wanted to start off a platform that can contribute back to the iOS developers, Swift Anytime. And I'll now hand over the mic to Catlin to talk about himself and also about the session today.
Hello everybody. Thank you for the nice words and for the introduction. I'm very excited to be here with you today. And hopefully by the end of this session, you'll improve at least 1% more your skills, if not even more. So let's dive in. So today's presentation and what I will be talking about is unit testing fundamentals. First of all, who am I and why you should listen to me or not listen to me? If I were to describe myself in just a few words, I would say I'm a mobile technologist with a big bias towards iOS development. I've been an independent consultant for most of my life, worked with dozens of SMEs, delivered a lot of projects from small projects to bigger and bigger ones. I'm very passionate about building scalable and testable iOS apps and improving code bases. And in my spare time, I'm also a husband, father, and once per year, I like to do obstacle course like Spartan race. I'm not sure if it's available in India yet. I heard something that it will be soon. And also, I like to run. My best performance so far is half marathoner, but I'm trying to improve. Okay, that's about me. So first, I want to talk a bit about the why. Why are we talking about unit testing? Why are they important? And let's go to the beginning and see what do users expect from a mobile application. You can type in some comments if you want. What are you expecting from a mobile app when you are using it? Are there any characteristics that you are interested into? Okay, no one typing.
Feel free to write your thoughts, guys. We will be pinning your comments on the screen.
Smooth functionality. Okay, good. User experience. Okay. Easy to use. Perfect. Anything else? Stability of the app. Okay, good one. Okay. So I see everyone is we are aligned to the work as advertised. Okay. Good one. Responsive. So we are all aligned. So let's see. What do users expect? As you can see, some of your answers are already here. Easy to use, intuitive, fast, responsive, smooth interactions, secure, reliable, do what was supposed to do, and I think most importantly, have no bugs or crashes, or at least as low as possible. Because this is the worst possible experience for an app when you're actually expecting it to do something and it crashes. It's like the earth is is crashing on top of you. This is a graph just to understand what are the implications as well for the company and the cost of fixing bugs. Uh, these are not exact numbers because depending on the team size, on the project size, there can be more costlier or not. So, but on average, the later the phase in which a bug is discovered, it costs the company more. If it is discovered in the requirements architecture phase, it costs less because you can immediately switch the requirements or fix them. If it is in the coding before you actually commit, that's easy as well. But the more it goes into production and when it's released, it becomes harder and harder, and the experience for the end user um, will diminish, and then it will result in bad ratings for our app, which is something we don't want. Another your employee, I guess, if you're working for a company. So, how do we detect bugs in mobile apps, and what are the feedback loops? We may use crash reports like Firebase. It has a bigger feedback loop because it means we get these crash reports when the app is already live and released. We can get bug detection by using customer feedback or ratings when the users actually complain about something not working, which again is not something we desire because it's already too late. We have a feedback loop that's already too late. Manual testing, which is okay. We get the feedback a bit earlier in case of a bug, but still it involves a lot of manual labor and time. And lastly, automated testing, which is something we'll talk in the next slide. What's automated testing? What are the types of automated testing? Automated testing are the types of tests that are done automatically. They are either functional testing, functional category, or non-functional. Functional category. It means the tests, the automated tests that are actually testing the functionality of our app. And this includes unit testing, integration testing, smoke testing, mutation, and so on. And for the non-functional, performance testing, security testing, because we want the app as well to, as you said as well in your comments, that you want to be responsive, to work as intended, and so on. On the right-hand side, we have the testing pyramid. Probably most of you have seen it. If not, I will try to explain it very briefly. This is how the tests should be distributed, meaning at the base, we should have the tests that are cheap and fast to develop. And then the more we go to the top, there are the tests that cost more and take more time to execute, like integration testing and end-to-end testing or UI testing. Let's talk about unit testing because this is the subject for today, which is at the bottom of the pyramid, which is the most important part from all this automated testing. So, what are unit tests? They are, of course, some pieces of code that are part of the automated test, are small, are isolated, and their most important characteristic is that they are fast. They are in the order of milliseconds. So if you are not getting the result of a unit test, if it doesn't get executed and finishes in a matter of milliseconds, it means that something is wrong there. And maybe you are not actually doing a unit test as it should be. And what's the most important part of unit tests is that they provide fast and early feedback. This means that as soon as we write a few lines of code, we can immediately test them. Or we can go with the other approach, test first and then develop. And this gives us like almost instant feedback. What are the characteristics of a good unit test? So these three are the most important things of a unit test that need to be followed and implemented in order to have a good unit test. First of all is isolation. It means that a test should be atomic and independent. This means that it shouldn't depend on the result of another test. It shouldn't alter the condition of the system. It shouldn't have side effects. and it shouldn't rely on anything else. Basically, it should just run by itself, do one job and one job only, and finish. That's it. Repeatability. Repeatability means that no matter how many times we run a unit test, it should always produce the same output. Doesn't matter we run it 100 times, 1000 times, and so on, it should produce the same output. So, readability. The unit test code should be treated with as much importance as the releasing code. This means we should put the proper naming in place, the proper structure, and so on. Just because it's code that doesn't go into production, it doesn't mean that we can absolutely do whatever we want just to fix, just to reach our purpose. How does unit testing in iOS look like? What does iOS and Swift gives us in order to develop unit tests? So we have the XC test framework, and inside of it, the most important things are the XC test case class, the XCT assert group of methods like assert equal, assert nil, assert not nil, greater than, and so on, mostly mathematical functions, and XC test exception that will help us test asynchronous code. And we'll talk about that in the following demo. And finally, if I were to boil down what are the most important three things that a developer needs to know in order to write good and fast unit tests, are the following. They should have the knowledge of pure functions. What's a pure function? A pure function is a function that, having the same parameters, should always produce the same output. And also, it should never produce side effects in the system. As an example, if you're having a method like sum of a and b, if you're giving a and b the same numbers, 1 and 2, it should always produce 3. That's a pure function. Nothing will change its mechanism. A function that is not pure, it's a date. Because a date, each time when you run it, it will produce another output. The second essential thing is mastering the solid principles, and especially the dependency inversion principle. And to be more precisely, the dependency injection. Using dependency injection properly will make your life way easier in doing unit tests. And finally, using the proper testing doubles, either if you are using like dummies, stubs, spice, or mocks, in order to make your test faster. But you should know all these 4 and the difference between them, and that will make your life easier. Okay, do we have any questions until now, or can we go to the demo?
We have one question, Catalin. It's a pure function also doesn't hold a state. Okay, it's not a question, it's a statement. Can you explain pure functions more?
Yeah. So, like I said, a pure function is a function characterized by 2 things. First thing is that having the same arguments, it should produce the same output all the time. And I gave example like a function like sum with a and b as the terms. And secondly, it shouldn't change the state of the system. So this is similar with, it doesn't hold the state. So it doesn't hold the state, it doesn't have side effects. So if you run it again and again and again, it will always produce the same output. Okay, is it clear now? Okay. Should we go to the demo? Demo, yeah. Okay, cool. Always. Cool. Okay, let's go to the demo. I will share my screen. Yep, a fixture is it's also okay. It's a stub. It's basically similar to a stub. You just give it like a canned response. We'll see it in the demo. Okay, can you see my screen?
Just give a yes, guys, if you can see the screen.
Yeah, it should show fine because I'm not seeing anymore what you're writing.
Yes, everybody is saying
Yeah.
yes.
Okay. Cool. So the demo it consists of two parts. A smaller one, super elementary, and the second one that's a bit more advanced. So let's go through the first one. We have a simple math demo where we just insert two terms, exactly what we talked about, and we have a plus or minus operation. And that's it. That's the result. That's all the app does. Let's see how it looks. So this is our view controller. It has a view model. These are the outlets that connect to the terms and the results. And these are the operations. Tap add, it will call the view model with the two terms. Tap subtract, it will call the view model again for subtracting. And then the result will be added to the text field. That's it. Let's look at the view model. The function add, since it's an optional string, we are trying to see if it actually can be casted to an int, as it will return 0. I mean, for the purpose of this demo, it just returns 0. So 0. So if we are to do this, this will be considered 0 because it cannot be casted. Okay, and that's it. The function add, the function subtract. This is a pure function because no matter the value, if they are the same all the time. So if you are doing 1 and 2, and plus 1 and 2 will always be free. That's what I meant by my comment earlier on. Okay, let's do some testing. How do we do some testing? First of all, here is the project with the target. We just add a unit testing bundle target, and you will get something like this. Yeah, it will create a folder here. And here we will create our class. Now, what are we testing? We are testing the view model. We don't want to test the view controller at the moment. We are just talking about the view model. As the naming as the proposed naming for this, it should be exactly the name of the class, like math view model and tests, add tests on it. And to look like this. So we have a new class that inherits from XC test case. And here we can write our code. 1 second. Let's put it like this. Let's close this. Okay. This one. Let's do the test a bit bigger, the text. Okay. So let's test add. What's the naming? How should the function should be? So the function okay, can you see? Yes, now it's a bit bigger. It's a bit too bigger for me, but okay. So we are creating a function with the following name. It needs to start with test so that it can be recognized by the system to be a test function. And then the way I like to do it is the following. I start with the test and then I put the method that I'm going to test. In this case, it's the add. And then I'm putting the scenario, what I'm expecting from this test, and what exactly are the particularities. So let's do like test add with invalid values. Okay. Good. What are we doing here? Let's instantiate our class. What SUT? It's subject under test. This is a normal naming that is used when testing. Okay. And now let result be, let's add, for example, nil and nil. And see what happens. Equal. Okay, so we are checking that if we are adding two nil values, the result should be 0. Because normally here, if it's nil, it doesn't go, it just returns 0 from this guard. So we are testing this behavior first. And secondly, let's do a mix. Let's say the first one, it's not nil, it goes through the casting and the guard. But the second one, it's nil. Okay, in order to run this, we just press either run on this particular function or run on the whole class or use the command U shortcut. Now it's firing up the simulator. Okay, test succeeded. So it works fine. Let's say someone, by mistake, modifies this in the production code, and it goes past the code review, and no one catches this. What happens when we run the test? The test will fail. So this is the power of tests, of having tests. You can do refactoring, you can do changes without being afraid of actually doing them and get an early feedback. Okay, let's test also the case with valid values. Now here it's also very important to look at this aspect. So we are trying to add 0 and 0. Okay, good. Let's run them. Let's see. Works fine. Okay. So we basically tested the whole function. Yeah. What happens if here I put a minus? And try to run command U. Try to run the test. It will still pass. Why did it pass? Because 0 and 0 return 0 for both addition and subtraction. What's the thing that we need to understand here is that it's not enough just to test one happy path or one edge case. It's important to test how many test cases are relevant to us. So in our case, okay, we can test this, but we should also test this. And now having this test as well, it will prevent us from actually refactoring to a minus by mistake. Yeah, test failed. And we have here, it says failed because it's -1 is not equal to 3. So we are expecting 3, but it resulted in -1. Okay. One more thing. Let's talk for a second about test coverage. What's test coverage? Because a lot of talking about test coverage and the golden 100% test coverage. Test coverage means the number of lines that were executed during testing divided by the total number of lines of code. So, and how can we see this? In our case, first of all, in the scheme, here in the test, we have also these options to execute tests in parallel. And that's why it's important to have the tests atomic and independent, because this way they can be executed in parallel and it will be executed faster. Because in a production app that's quite big, we will have thousands of tests and it will take some time to run all of them. And also randomized execution order, it's important because this way we see they don't hold any state or have side effects on the whole system. Okay, and options gather coverage for all targets. Here we can get the coverage. And then, let me see, where was it? Here, code coverage. Here on the right, we can see that we have covered all this method. And also, we can see here in the coverage that our math view model, that our method add was covered 100%. And the method subtract, it was not covered. We can basically copy paste and just replace this and we'll have coverage for that as well. This is the code coverage. It's important to have it as high as possible, as high as it makes sense for the team, but it's not the ultimate thing that needs to be followed, because it can lead you into doing all kind of tricks just to get the code coverage. Just like I've shown you, if you're just trying to get the code coverage for this, you can put just 0 plus 0, but this doesn't mean that even if you have code coverage for this, it doesn't mean that your test is actually testing properly all the cases. And then you'll have bugs in production. This is the first demo. And then we'll go to something a bit more complicated. Let me change here factory weather. Okay. So the second app, it's an app that gets you the local weather from an API, from a open weather API, I think it is, for a current location. In my case, it's Constanța, Romania. As you can see, it loaded with unknown at the moment. Get weather, 10 degrees. Okay, it gets warmer. That's cool. This is what it does. Now let's see what happens behind. We have the same view model. We have a closure for when the temperature changes. By the way, I haven't used any RxSwift or anything more complicated. I didn't want to import anything else. I just wanted to keep it as simple as possible. And we have the get temperature. From this, we have the view model. Let me close this. Maybe throws in a say. Okay. The view model, what happens? So we are setting this closure just like a way to communicate between the view and the view model, like in an MVVM. Okay, we have the on start. On start, what happens? It just puts the default text. The current temperature is default city is unknown. And then we have the web service that actually goes to the API, gets the temperature in case it's a success. It just updates it. Else, it puts that it's unknown due to an error. Okay, let's see the service. The service is a standard URL session shared. It just loads from open weather map with the city. It opens the weather. It just parses it to see if there is any error, if the status code is okay, and so on, and then decodes it. I mean, this is standard stuff. What I have used here in addition is that instead of using directly URL session, I'm using a network session, which is a protocol. Yeah. And URL session has an extension and implements this protocol by calling data task. So instead of using network session, it's basically URL session dot shared dot data task that you normally use. But I am doing this because I want to unit test it, and I will show you what's the difference. Okay, and then we have the model, which has weather data, name and main, temperature and humidity. That's it. How would we test this? Let's say we want to test the service. Let's go to the lowest layer. So the service which interacts directly with the API. So if we want to test this, by the way, for this the code is already written, just in the interest of time, not wasted. So a weather service bad test will look something like this. We are setting up the weather service. We are setting up in the setup with error, and in the teardown we are putting it to nil. And we are doing a test called test get temperature from city by hitting the network. And this will call get temperature from city. Get temperature from city is exactly this method. This is the only one that we can test. Yeah? Okay. We are also using expectations. I mentioned the presentation about expectation and the ability to test asynchronous code. How does this work? We instantiate an expectation. We describe what should it do. We call the method, and then we wait for the expectation to happen for whatever timeout we want. 1 second, 2 seconds, 3 seconds, whatever. And here, because it's an asynchronous response, we get the temperature, and we either do expectation fulfill, meaning that our expectation fulfilled and ended, or we can do an XCT fail, meaning something bad happened. And at the end, what can we test here? Because the weather, getting the response of the weather from the API, it's not a pure function. It can have different values all the time. It's like the date. Whenever you run it, maybe it's hotter outside, maybe it's colder. So we can just test that something is there, that is not null. And this means that the service was called, the JSON was parsed, and we got a temperature, and that's it. We cannot be more specific than that. Plus, if we want to test this, we just go, we press on run it, and let's see what happens. Okay, it got executed in 0.29, so it's 0.3 seconds, which is a lot. If we are to think of what time took here to execute, it was like 0.01. So it takes a lot of time because it needs to hit the network 0.3. Plus, what will happen if we run this test when we are out of network? Imagine you are running it in a CI/CD platform and something happens. You don't have internet. I mean, there is absolutely no value in having a test like this. So what can we do? How should it look like in order to be a good test? So first of all, we can go here. Where was it? Bad test. We can disable it because we don't want it to run along with the other tests each time because it will consume the API, and then we won't get any result anymore. Okay. Let's see. Good. So close other tabs. If you look here in the constructor, we are instantiating with the default value of URL session shared for the network session. That's the whole purpose of the protocol. It's for us to use dependency injection and use a mock that will conform to this protocol and give us the results that we want. And this mock will look like something like this. Network session mock implements, conforms to network session. This is the method that we need to write. And what does it return? It returns what we want it to return. So depending on how we configure it here, it returns exactly as we want. And this way, let's say we want to load data and we want to return an error. We just set the error and then all the code will just remain here. We want to return a status code that it's different from the OK status codes. We just return 400 and then it falls here. And this way we can easily test each step from this method by mocking the session. So first part, test get temperature from city. So we are testing this method, yes. And we are testing returns invalid URL. So returns here. Yeah. We have our result. This is the result of the method. Yes. And for the mock session, we have injected it here. We have set it up in the setup and injected it here. We are setting an error of invalid URL. Then we execute it and get the result. And then we assert if the result is actually a failure with an invalid URL. So here, the closure will return the completion, will return the error invalid URL, and it will fall into this branch. Now, if we are to run this, test complete. Okay, as you can see, 002. So it's a big difference between 0.3 and 0.02. It's 100 or 1000 less. Okay, next we want to test the next step. We want to test the status code if it goes on this branch. How do we test this? For our mock session, we just put status code something outside of this part. Okay, and we assert. We want to return no data. Okay, how do we return no data? What happens when we are return no data? It means that the data is null. Okay, by default, the data and how it was implemented, yeah, it's here, it's null, so it goes. through this. We want to test that the parsing returns an error. The structure is name main. We just put another structure like name 1 main 2 for the mock session data. So we are telling it, okay, this is the data that we will return. It gets executed and we assert for the JSON parsing error. And lastly, so this was for this part, yeah? When the JSON cannot be decoded. And now for the happy path, at the end, we are just giving it a proper JSON, proper response. And we are testing that the result is a success with the 5.1. 5.1 is the temperature. And now, if we run all these, test succeeded. As you can see, the time is almost instantly. Let's look at the code coverage for the weather service here. So weather service 96.6, 93.8. Okay, I guess, yeah. So we didn't test this. How do we test this? It's only when the URL fails to be completed, and this means like the city name is something weird, like it's having a weird character that cannot be converted to an URL. But rather than that, we are almost 100%. In this case, the result, it's instantly, and we are not hitting the network. Now, everything, it's in a pure state because it produces the same results all over time. And what's fun about it, weather service tests. We have this option, run weather service tests repeatedly. Yeah, so let's say we want to run it, I don't know, 30 times. Same test, 30 times. It took 0.2. So it took almost the same amount of time as the test that was hitting the network, the asynchronous one. It took the same time as 30 tests, which in fact were 30 or 5 methods, 150 tests. Again, that's something really powerful. And lastly, we are testing the view model. We are going one layer up. And the view model depends on what? Depends on the service. And again, the service itself conforms to a protocol, whether serviceable. It's not a proper naming. I wasn't very inspired, but that's it. It's very hard to name protocols in Swift. It's a true art. So let's say it's whether serviceable. Here as well, we have dependency injection. Instead of injecting a concrete implementation, we are using a protocol, and then we can inject from a proper factory the concrete implementation that we want in a specific situation. In the production code, it gets the weather service. In our tests, it will get the weather service mock. How does the service mock looks like? Since it has only one method, get temperature from city, it records the city name, and it calls the completion with the result that we are interested into. This is also a mock, but it also spies on the values, because we want to see if the city name is actually used properly. Okay, it's absolutely similar to what we have done before. We are setting up the SUT here. Temperature change. We are setting up the result. We are setting up a fail or not, getting temperature. And then we are just asserting if the values are properly updated. Okay. And basically that's it. Let's run this again. Again, you can see the time. So, in order to run all the tests on all the demos that we had, total duration 002 seconds. And we ran 2, 4, 6, 7, 8, 9, 10. 10 tests. Okay. Cool. Then the coverage for the whole project went up to 60%. Where is it? The view model? Math view model, no. Weather view model. Yeah, weather view model, the thing that we just tested, it's 100%. Okay, so I will put this project on GitHub for you to view it as well. And you can add some comments to it. That's it for the demo. I hope I haven't bored you to death. Going back to the slides, as a final note, it's something that I posted yesterday as well. So are you doing TLD? What we have done, by the way, it's called TLD, test less development, means that we are testing after we have developed. And there is also test-driven development, where you do the test and this drives the behavior and the architecture of the development. So are you doing TLD or maybe even TAD? No. Then you're probably doing FDD, fear-driven development. So the idea is, I guess you all have seen it, you all have seen something like, if it ain't broke, don't fix it. And you're trying to stay away from the areas of code that have a lot of comments. Nobody wants to touch them, because if you touch them, they will break. But having tests in place, it will help you overcome this and refactor with confidence. Because what's the most important things about tests? In one word, it's confidence. Confidence to your team, confidence to the company, confidence to you that your code works fine. Where can you reach me in case you have any other questions? That's my website, catalinpatrascu.com, and then the Twitter, the LinkedIn, or even the Instagram. I'm trying to keep young and use social networks like Instagram. Okay, and a few words about Swift Anytime. If you are here, most of you probably know. If not, if you're for the first time, Swift Anytime, it's a learning platform that helps iOS developers expand their knowledge. And it's also one of the largest active iOS communities in India, and probably soon one of the largest in the world. Let's hope so, fingers crossed. In order to access it, you have the Twitter, LinkedIn, and YouTube links. And that's it from me. A humble thank you, and I really hope I haven't bored you and you have learned something and you found this useful. Thank you.
All right, so I hope we are open for the questions now, right, Catalin?
Yes. Let's
So guys,
do them.
please feel free to ask your questions, and we'll be taking up every question that you shoot our way. I think we have already few which you guys have posted before. So let's take a look at them first. So somebody is asking, project will be shared. Yes, project will be shared. It will be shared with you. You will get a feedback mail, and along with that, you will also receive the project. So somebody was saying in between the session that shouldn't you write a failing test first?
Okay, so that's the TDD approach.
Yeah.
You write the test, you want to validate the behavior as small as possible. Then you write the production code, and then you refactor, and all this cycle. And then write a new test, write the code, refactor.
All right.
Not in this session. Not in this session, maybe in the future. Let's see. Well, so about end-to-end testing regression. Definitely it's something that needs to be used, but because of the cost, I mean, it takes time to write these tests, and it also takes time to actually execute them. I know, for example, a company that had a lot of phones that were running over the night doing this kind of regression testing. So imagine that all these tests, instead of order of milliseconds, it takes seconds, and some of them even minutes, because you are testing a whole flow, like a whole path, like the whole login, the whole payment flow, the whole ordering flow, and it takes time, especially because especially if you are going through different branches and scenarios each time. Definitely, any type of automated testing is helping, but you need to find the balance between writing a lot of tests, only end-to-end tests, and writing only unit tests. As you have seen in the testing pyramid, they are in opposite corners of the pyramid, so they need to be balanced properly. But yeah, definitely is worth it.
So that's a weird question. Maybe what would you test, or should I ask what should be test?
So normally we should test the business logic. We should test also the view controllers. I mean, we should test as much as possible as we can, and it makes sense for us. It's not a solution that fits all. It's about your own. If you're any developer, it depends on what you want to test in order to be confident that you can release without bugs. If you're a company, you should talk with your teammates and see what makes sense. I mean, let's say, for example, is it worth testing UI and view controllers? Let's say a color changes. Is it something that will annoy our users? If yes, then maybe you should do some snapshot testing. Is a certain flow inside the application important or critical, like payment in an e-commerce app? Okay, then you should write an end-to-end test checking that flow. So that's what you should test. Well, at some stage, it's common sense. I mean, somehow you need to see the situation from all the angles, like we have done it with the sum. If we are adding 0 and 0, sure, it's the sum of two numbers. But if you're true to yourself and thinking about it, okay, let's see what are the edge case scenarios. So it's only 0 and 0, or maybe we want to test some negative numbers, or maybe we want to test only positive, or a positive and a negative. That's up to you, but you should be true to yourself. Again, this is similar to what I have said before about whatever makes sense to your team. So I get it, what you mean. Maybe there is also a problem in the architecture of the app, because if you have a smooth architecture with a properly service locator, dependency injection, and everything set up properly, unit testing doesn't take that much time. I mean, at first, I struggled with this a lot of years, saying I don't want to do unit testing. It takes a lot of time. But my problem was that I wasn't writing quality code good enough so that it can be tested easily. But the key here, Christian, is to have some procedures in place with your team and some ways to actually speed up the testing. So let's say you want to test a view model, you want to test a coordinator. Okay, maybe you should write a documentation in Confluence, like, okay, you need to do these steps. And then everybody is on board. Let me see. I have one. Well, I mean, not necessarily book on this matter, but I will recommend you some Udemy courses. They're pretty good from Mohamed Azam, I think. Yeah, they are pretty good. I mean, you can go first through some Udemy courses or even YouTube materials, because there is plenty out there. And once you get the hang of it and play a bit, okay, then you can read also a book of 400 pages, because that's how long they are. I think today I've seen a book, but I haven't read it yet. Let me see if I can find it. Give me 1 second.
Meanwhile, feel
Test.
free to ask your other questions, guys. We are taking all of them one by
So
one.
test driven iOS development with Swift by Dominic Hauser. I haven't read it. I just found it today as I was looking for some material, and it looks interesting. I will definitely uh, read about it because I'm very keen into TDD as well. Hey Bernardo, greets greets also from Eastern Europe and India. I guess the weather is much better there in Colombia. I can't hear you.
So we have 5 minutes left, and
Okay.
you can still ask your questions, guys. Feel free to ask. Catalin is available at service right now, and then you'll have to DM him. So yeah, avail the service right away.
Let me close the notifications. I will be at the wheel driving soon, and it's
Okay.
very hard.
All right. Looks like we are good with all the questions.
Okay. So it depends. If you want to test it while actually reading from the file, or if you want to use a mock that simulates it, like we have used for the API service. But you need yeah, feel free to reach me, and I will crop up some example because it's not as easy to explain in a few words here. Unit and UI testing replace QI testers. No, QI testers have their role, but definitely it will replace some maybe lower levels of the QA testers. I mean, this question is similar with will AI ChatGPT will replace programmers? No, they won't replace programmers. They will replace some very easy jobs, but this means that the rest of the people will need to upskill and do something more complex. For example, QA testers. I mean, QA testing is not only manual testing, just punching buttons. It's a lot more than that. It's creating workflows, procedures for the whole testing routine.
All right. Looks like that's a wrap. So we will be closing the session here, guys. And before doing so, okay, we have one more question, I think.
Uh, Normally, I'm trying to avoid any third parties unless they are absolutely necessary. You can keep the code small under your control without actually using any third party. Normally, in the projects that I've worked, I like to use my own helpers, and plus all these helpers. Sometimes, I mean, if you're working as a contractor, as a freelancer, you will see that each project will need their proper helpers because no code base reassembles with the other, but there is some basic common ground there. But yeah, I like to use my own helpers and write my own code. Okay. Yeah, I think I heard about them, but I haven't used them. nimble and quick. Are they something like Mockito, which is on Android?
Okay, then let's call it a wrap before anyone else asks one more question. You can definitely reach out to Kathleen over our community as well. You might have find the link already. I posted in the chat. I'm sharing it again so that you can easily join it. Spam his DM with all your questions. I think he would be there. So yes, feel free to join the community. And we have some people talking about certain things. You can do BDD with Nimble and Quick. Okay, no testing library. Nice.
Yeah, for
So
BDD, I was 1 second. Let
sure.
me see for BDD. What was the library? I forgot. BDD Swift library. Yeah, I don't remember a name that I was using, and a lot of people were using. Cucumberish for BDD. So I guess it's something similar with that.
All right. On that note, thank you so much, everyone, for joining in this session. I hope you all liked it. You all got some value out of it. And thank you so much to Kathleen for joining us today and sharing his thoughts, opinion, and learning about unit testing in iOS. I think even I got to learn a lot of uh, new edge cases today, which you talked about. So thank you so much, Kathleen, for that. I hope we will be doing more such interesting sessions around unit testing, maybe getting into more depth of the concept. And if you all want that to happen, then you would have to respond back to the feedback form that we will share with you at 9 p.m. today. So feel free to share your feedback. Based on that, we will make sure that if you want to invite Kathleen once again for more in-depth sessions or not. So otherwise, also you can reach out to Kathleen and you can post anywhere on social media. Based on that, we will get to know what you want to say. At last, thank you so much once again, and we will take your leave now. If you haven't yet subscribed or follow Catlin, then feel free. I think his handle is over there. You can see along with his name. He's quite active on Twitter, which I have seen. You can also follow me at iOS Mayank. You can also follow Swift Anytime with the same handle at Swift Anytime on Twitter. And for more such sessions, stay tuned, join the community, and yeah, keep following. Thank you so much for making the community what it is today, because without you all, there is no community. Like the term community comes from the people that are involved into it, who are like-minded, sharing their ideas, bringing things forward and learning along the way. So thank you so much for that as well. And yeah, I'll not take much of your time now. Thank you so much. I'll see you in the next session next week. Till then, take care. Bye bye.
Take care. Bye bye. Thank you all.